Welcome. This video is on 5-5 solving right triangles. You're going to want to use, you may need a unit circle, maybe not. So sometimes a trig value, but not an angle. You can use an inverse to find the angle. So we have all of these trig functions, sine, cosine, and tangent, and all of them have an inverse trig function that goes with them. So we could call this the inverse of sine. So we do the inverse sine of our ratio is going to equal our angle. Another way we call it is arc sine. So you'll see arc sine or sine -1. That's talking about the inverse of our trig function. All right. So on these problems, we're going to use our unit circle to solve these. So on our first one here, it's asking for the sine of what angle equals the square root of 3/2. Well, if we look at our unit circle here, we know that sine is going to be the second number. So I'm going to look for the second number where it's square root of 3/2. So it looks like it is square root of 3/2 is at 60 degrees. Square root of 3/2 is also at 120. Okay. So we could say that x is going to equal 60 degrees, or it's going to equal 120 degrees. Okay. And then potentially when we say that it's 60, it could also then equal any angle that is 360 degrees after that, which means that it is coterminal. It has the same ending spot. So I'm going to add any angle coterminal with these. All right, so 60 works, but also 60 plus 360, which would be 420. That would also work. Okay, so I'm going to look right here at the cosine of -√2. Cosine's our first number, where our cosine is -√2. So that would be 135, or at 225. So x is going to equal 135 degrees, or 225 degrees, or any angle coterminal to these. Okay. All right. So now we are going to assume all our angles are in tangent, in quadrant 1, because it told us. So let's take a look at what that looks like for these. So our question here asks us for the tangent of the inverse tan of 611. Well, tangent and inverse tangents, they just undo each other. So that means that we're really just taking a look at 611. So a tangent and an inverse tan, those are inverses of each other. But let's look at this next one. This next one says that I would like to get the cosine of the arc sine of 2/3, or the inverse sine of 2/3. 2/3 is not something on my unit circle, so that's out now. Okay, so now I'm going to take a look and think of this in terms of a triangle. So I'm going to make a triangle here. And in my triangle, I have some angle right here. We'll just say angle A. We don't know that angle, but we know that the relationship of that angle, we know the sine of it is going to be 2/3. Okay, so we know that the opposite over the hypotenuse is going to be 2/3. So now if I find this side right here, okay, if I find this side right here, I can figure out what my cosine of my angle is, and I never actually need to know what my angle is. Okay, so how I'm going to do that is I'm going to do my Pythagorean theorem here. So I'm going to say 2 squared plus x squared equals 3 squared, and I'm going to solve for that. Okay, when we square root, we always plus or minus unless we are finding sides. They are not going to be negative. So that side there is the square root of 5. That's what I made x. Okay. Just in parentheses, so you know that that's what I meant that side to be. So now I know this triangle helped me to set up this information inside, and now I just want to know the cosine of my triangle, and that's going to be my cosine of my angle is going to be the adjacent over the hypotenuse, and that is going to be my answer here. Okay, so the information helps us to set up my triangle. All right, now I have a triangle for you. Okay, and it gave me some information in my triangle. I know that F, side F, because it's the little one, the one across from F is going to be 17. Side D across from D is going to be 32. And it wants me to find angle E. Okay. I'm going to start by setting up my trig function here because I know these two things and I have to figure out which trig function relates those two sides. I have my adjacent and my hypotenuse, so I know that I'm going to have my cosine. So I'm going to say cosine of angle E equals my adjacent over my hypotenuse. Okay. And in order to solve this, I can do like we did above here. I can use an inverse of my cosine to undo this. So if I take the inverse cosine of this and I take the inverse cosine of this, I can figure out what the answer to that is approximately. So this cosine and this cosine, they cancel each other out. Looking for a different color here to kind of show you these two. Those are going to cancel each other out there. And on this side over here, what I'm going to actually put into my calculator is the inverse cosine of 17 over 32. Okay, inverse cosine is going to be above the cosine button when you push second. This is going to be an approximation of our angle. And that approximation is 57.91 degrees. Okay. It'll often tell you how many decimals to round that out to. All right. So going on here to our next problem. My next problem says that I have a security light. It is being installed outside of a loading dock. The light is mounted 20 feet above the ground. The light must be placed at an angle so that it will illuminate the end of the parking lot. If the end is 100 feet from the loading dock, what should the angle of depression of the light be? So let's start off by drawing a picture for this. Okay. So I have a triangle here. I know we're dealing with some sort of triangle. This is my building with my light up here. Okay. We'll give it some, see if I can give it some light. Okay. If you can see that light on there. I know that this distance to the end of the parking lot is 100 feet. And I know this light is 20 feet above the ground. My picture is not at all proportional, but that's okay. We also know that when we're talking about an angle of depression, we are talking about an angle from the horizontal down. So that's what our angle of depression is going to be. We're actually taking a look at this angle right here. That is our angle. I'll label it A. That's the angle we're taking a look at with our angle of depression. So if I take a look here and I turn this into a square, I know that this distance here is still 100. This distance is still 20, and now I'm trying to find that angle A up there, and now I have a triangle. So if this is my right angle, these sides are going to be my opposite and my adjacent so that I can solve my triangle. So I'm going to have a tangent of my angle equals the opposite over my adjacent. Okay. Just like that one before, I'm going to take an inverse tan of this, which is going to be a tangent on both sides, which leaves me with an A, and an inverse tan of 20 over 100. Okay. I'm going to put that into my calculator. And that is going to give me an approximate angle of 11.3 degrees. Okay. If you wanted to solve the black triangle, you totally could, but you would need to take 90 and subtract this angle from it to get the actual angle of depression. So make sure you know what angle you are solving for. Okay. Here's my next one. I have another triangle. It gives me angle measures and it tells me to find my rest. So I know that A is 33 degrees. I know that the length of B is 5.8, and I need to find all the others. So I currently have 2 of my angles, so I can find B. That is going to be 180 minus 90 minus 33. And that gives me an angle for B of 57 degrees. So that's good. All right. Now with the information I know, I need to solve another part. I currently have an angle and I have the adjacent side next to it. Okay. So I can go and solve this side or this side. So if I want to solve this one here, this is my opposite side, which gets a tangent for these two. So I'm going to say that the tangent of 33 equals the opposite. That'll be side A over 5.8. Okay. I'll say this is A talking about being adjacent, but this is going to be side A for me and side C. So times by 5.8. And my A is going to be approximately whatever that is. After we put it into our calculator, that is 3.8. Right? You have 2 sides now, so you could potentially Pythagorean theorem, or I can use this side I know and another function. So I have my adjacent and my hypotenuse. So I know that that's going to be a cosine of 33 degrees, adjacent over hypotenuse, which is my C, and I'm going to solve that. Because I know if I multiply on both sides and divide, these 2 things are switched, I am just going to switch them. Plug that in my calculator and I'll get an approximation for C, which is 6.9. Right. So now I have 1, 2, 3 angles, and I have 1, 2, 3 sides. Last one. Okay, I got some more information. I got to fill it out. So I know this side is 23. The one across C is 45. And I don't have my angles, and I don't have side B. So I need to decide where I want to start from. I can start wherever I want to. I already have these two sides, so I might start with b and say that I know that a squared plus b squared equals c squared, and solve for that. Okay. Okay, so maybe I start, so I can get rid of that, and I have b squared equals that. I'm gonna throw that in my calculator, and I get that that is 1496, and I find that b is about 38.7. If I'm rounding, I use this squiggle for an approximation. So that's that side, 38.7. And now I need to find my angles. I have these two sides, so I'm going to use those to find my angles. I'm going to start with angle A. The relationship of these numbers to A is my opposite over my hypotenuse. OH is my sine, so I'm going to say my sine of A equals opposite over hypotenuse. Okay, and then I'm going to take my inverse sine. To get my A out, and I'm going to take the inverse sine of this over here, we'll just say equals, is 23 over 45, and so now I know my A is about 30.7 degrees. I have 1 degree and I have this degree, so I am going to take 180, subtract them all from that, and that will give me angle B, 59.3. Alrighty.